In previous lessons, you've been introduced to different ways to solve a quadratic equation. You've been introduced to completing the square. You've been introduced to using factoring and then solving for zeros. You've also been introduced to the idea of graphing and then just looking for where it hits the x-axis. Those are all good methods, but one thing I like about this quadratic formula that you're about to learn is that it's kind of the fail-safe. If you don't understand how to do those other problems, but you do understand this one, it'll work every time. Or let's say that the graphing, you can't really tell exactly where it crosses, or factoring, it doesn't really work out to be able to factor it very well. Or you can't figure out the numbers to be able to complete the square, or it's not possible to complete the square. Then there's always a backup, which is the quadratic formula. The only problem is that a lot of people don't like to plug in this many numbers, but it's really not that bad. You get used to it, you can plug it in pretty quickly, and it's not too bad. So let's take a look at what this looks like. But first, we need to remember what the standard form, like the general form of a quadratic equation is. You've seen it before, ax squared plus bx plus c, and now for an equation equals 0. Okay, so a little pre-example before we get started is to remember how to find a, b, and c. Okay, so we're given this equation 2x squared minus 5x equals 10, but the problem is we need it as equals 0. So we're going to subtract 10, okay, from both sides. All right, and that will get rid of that. So I'm left with 2x squared minus 5x equals, I'm sorry, I apologize. Back up just a little bit. Okay, minus 10 equals 0. Okay, so we pulled it across. Now we have it in standard form, and so therefore we can write it in our answers here, which a is going to be the leading coefficient, which is a positive 2. Okay, b is the next coefficient, which is negative 5, and c is the constant, which is at the end, which is negative 10. Okay, so now we have a, b, and c, and if you look in the quadratic formula here, the only variables that we have are a, b, and c as they show up here. Okay, so we're going to take this formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, if your teacher is very bold in class, you might can talk them into singing a little song for you to help you remember that, but my kids don't need to ask me. Okay, so one thing to keep in mind is every time that you've ever solved a quadratic equation, you've gotten two answers. So you need to keep that in mind here, that's why we see that plus or minus there, because we're going to work at one time with a plus sign there, and we're going to work at another time with a minus sign there. Okay, so let's work at first with a plus sign, just because it's easier and it seems like the good way to start. So we're going to start with negative b. Okay, negative b is going to be, actually we need to get this in the standard form first. I apologize. So subtract 3x from both sides. Okay, so standard form is going to be x squared minus 3x plus 2 equals 0. Okay, so now we have it in standard form, so we can use the a, b, and c. Okay, so negative b is going to be the opposite of this middle term. Okay, so that's going to give me a positive 3. Okay, so I'm going to start off with 3 plus the square root of b squared. Okay, negative 3 times negative 3 is positive 9. So I'm going to put my 9 here, minus 4 times a, which is 1, times c, which is 2. Bring that over a little bit further. All over 2a. Okay, 2 times a. So all we did was just take our a, b, and c, plug it into the formula, and now we're gonna work out an answer in just a second. So let's do that. Okay, so we have 9 minus this. Okay, so 4 times 1 is 4, times 2 is 8. So we have 9 minus 8. That's going to give me 3 plus the square root of 1. Okay, 9 minus 8 is 1, all over 2. Okay, so here's my next line after I've worked out some of this. Okay, so that's going to leave me with 3 plus 1, because the square root of 1 is just 1, over 2 which gives me 4 over 2, which is just simply 2. Okay? And so that gives me one example, or one solution, one root. Okay? So the parabola would at least hit at x equals 2. And so we'd have to look for the other answer now. Okay, so we're going to plug this back in, and we've already done some of the work. You're going to realize this, but let's go ahead and plug it back in, and we get negative b, which is 3, minus now. Okay, don't forget, we've done plus, we need to do minus the part under here, which is b squared minus 4ac. Okay, so we've actually already done this. So let's wait. Instead of writing this in, let's go ahead, and we've done the work here. We've plugged it in, b, 4a, and c, plugged it in. And so now we have a square root of 1 over 2 times a, which is still 2. So if you notice, we've already done half the work. So on the second time around, it's much easier. Okay, buy one get one half off. Okay, so 3 minus square root of 1 is 3 minus 1 over 2. Okay, and that's going to give us 2 over 2, which is just 1. So my solutions are 1 and 2. All right, so not very difficult. This one could have been done by factoring, but I wanted to show you an easy one for the first case. Like I said, it works for all of them. Okay, so now we're going to move on down to example 2. Okay, on this one we're probably going to end up with a decimal answer because it's a little bigger problem, but we don't always know that ahead of time, but it's fine. We can deal with it when we get there. So it's already in standard form, so we're going to plug it straight into our formula. Okay, so the first thing is negative b. Okay, so here's b, which is a positive 4. So negative b is going to be a negative 4. Okay, we're going to start with plus. Don't forget, we're going to have to redo this with a minus in a second. So plus the square root of b squared, which is 4 times 4, which is 16, minus 4 times a, which is 3, times c, which is negative 8. Okay, be careful that you've plugged that in correctly, because if not, you will get the incorrect answer. So now all over 2 times 3, which is a. Okay, so all I've done so far is just plug straight into the formula. Okay, I went ahead and squared that just because there's no sense in adding an extra step just for that one little step. So now let's go ahead and multiply this out. We get negative 8 times 3 is negative 24, times 4 is negative 26, or 96. Okay, so that's going to leave me with negative 4 plus 16 plus 96 over 6. Okay, so that's negative 4 plus, hopefully I can get this in, 112 over 6. Okay, now at this point you're going to have to recall some of your rules. Okay, if you've got a calculator that can punch this in, then by all means at this point go ahead, punch that in, find your answer completely, add the 4, divide by 6, and you'll be done. Okay, but if you don't have a calculator, you need to get it a little further. Okay, and we're going to end up using the calculator anyways, but I will give you the answer in both forms. Okay, now we need to take this square root of negative 112. Okay, so let's do a little scratch work right here. Let's give ourselves a little bit of room to do some scratch work. So we got square root of 112. We need to change that to square root of the biggest perfect square we can think of that goes into this. Okay, so you may have to test that out a little bit, but you end up realizing that 16 will go into it. So 16 times 7, okay, times 7. All right, now what is the square root of 16? It's 4. Okay, so 4 square root of 7. All right, so now we've reduced that rational. Okay, so let's continue with our problem like we had it. We had negative 4 plus 4 square root of 7. All right, and we can reduce that because I see a common factor of 2 in all these, and that would give us, if I factored out a 2, okay, that means I would divide this, this, and this all by 2, and I'll be left with negative 2 plus 2 square root of 7 over 3. Now, at this point, you need a calculator. You need to go ahead and add that together. Um, so your calculator should give you somewhere in the neighborhood of 1.10 when it says to round your solutions to the nearest hundredth. Okay, so that will be one of your solutions. Okay, so now we need to plug it back in for the subtraction. Okay, so we will work it back out. We'll plug it back in. The only difference will be that this is negative. Okay, so I'm just going to copy that straight down. Okay, well, actually, since we've already done this multiplication, I'll go ahead and copy it to here. Okay, so negative 4 minus, okay, new problem, okay, minus square root of 112 over 6, okay. We did the work right there, so we have negative 4 minus 4 square root of 7 over 6. We reduced it just like here. We divide everything by 2, okay. So you're left with negative 2 minus 2 square root of 7 over 3. And when you use your calculator, you end up realizing that that is negative 2.43 if rounded to the nearest hundredth. So you will need a calculator to finish up some of these. I don't really see how you couldn't use a calculator unless you just left it in this form. But when it asks for you to round your solutions to the nearest hundredth, you're going to need a calculator for that. Okay. So moving on so that we can finish this up. Let's look at this last thing. Let's try to look and see which version we should use. Okay. So it says, which method would you use to solve this or each equation? So the first one, I would say that we would need to use the quadratic formula, because if we look at this, it's not easily factored. Okay, there's not different squares or anything like that, so you can't do anything like that. So we would use the quadratic formula. Okay. All right, let's look at number 2. Okay, I'm kind of speeding through these. You can kind of ask your teacher if you need some extra help. But right here we have a quadratic that can be factored very easily because of difference of squares. Okay, so you take the square roots and you do your thing with that. So I would say you need to factor these. Factor those using difference of squares, and then you set them equals 0 and solve. Okay, right here, this one, I would say use factoring also, because you could use positive 1 and negative 3 as your factors, and so that would end up being easy enough. Okay, you want to factor if you can, because obviously the quadratic formula is a little bit of work to plug in. Okay, but right here, if we look, we would need to, well, we can't actually make that happen. We can't use factors of 3, so you would either have to complete the square or use the quadratic formula. Okay, so you got two different options there. You got quadratic formula or completing the square. Okay, so you got two different ways there. All right, and on this last one, I would say that looking at this, this is not easily factored. Okay, 16, 96, and 135 don't exactly share very good common factors, and it just wouldn't work out very well to do other methods. And so, because it's not factored easily and the numbers are large, I would say use the quadratic formula. Okay. And using the quadratic formula, it doesn't really matter how big the numbers are, because you're just simply working it straight out. So you just plug it in, find your solution, and move on. So hopefully you can use the quadratic formula as easily as what I feel like you can, and good luck with it, and make sure you practice it during class. Thanks.